Hey everyone, and welcome. Today, we're going to dive into something called linear functions. Now, that name might sound a little complicated, but I promise you, it's way simpler than it sounds. Actually, it's super simple, and you see it all over the place. We're going to take this really slow, one step at a time. And trust me, by the end of this, you'll see it's just a basic recipe for drawing perfect, straight lines. So, let's get into it.
All right, so here's our game plan for today. Think of it as our little roadmap. First up, we're going to cover the biggest idea of all. What in the world is a function? Then we'll meet the star of the show, the linear function. After that, we get to the really fun part, actually drawing its graph. Then we'll decode its secret formula, and finally, we'll see how you can actually use this stuff in real life. Ready? Let's jump in with step 1.
Okay, first up, what is a function? Before we can get to the lines, we've got to understand this one basic building block. You can just think of a function as a special kind of rule that connects two things. That's it. Let me show you what I mean.
So just think about it. A function is a rule connecting two things. You see these everywhere. For example, the number of hours you study is connected to your test score, right? Usually, the more you study, the better you do. That connection, that rule between studying and your score, well, that's what we call a function in math. It's really that simple. Now, here's the most important part. For any rule to be a function, every single input can only have one output. Think of it like a vending machine. You put in your money and press a button. That's your input. And you get one soda out. That's your output. The machine can't give you a soda and a bag of chips at the same time for one input. One thing in, exactly one thing out. That's a function.
Let's look at a quick real-life example. Say you get money for returning empty bottles. For every one bottle you return, you get 70 cents. So the number of bottles is your input, we'll call that X, and the money you get back is your output, we'll call that Y. So look at the table. If you put in one bottle, you get out 70 cents. If you put in two bottles, you get 140 cents. Every input has just one single output. See? Perfect example of a function.
Awesome job. So now you know what a function is. So let's move on to our second section and meet a very, very special kind of function. This one is called a linear function, and you are about to see it everywhere.
To really get this, let's use a little story. Picture a fish tank, okay? And it's not empty, it already has 10 liters of water inside. That's our starting point. Now, you turn on the hose, and every single minute you add exactly 2 more liters. This relationship between the time going by and the total water in the tank is a linear function. It's got a starting point and a nice, steady change.
And that little story gives us the secret code for all linear functions. It looks like this: y equals ax plus b. Now, don't let the letters freak you out. X is just your input and y is your output, like before. The a and b are just numbers. Let's look back at our fish tank. The equation for it is y equals 2x plus 10. See how that fits perfectly? The 2 is the rate of change, 2 liters every minute. And the 10? Well, that's our starting point, the 10 liters we already had.
So what's the secret to spotting a linear function? Well, just look at the x. In a linear function, the x is just a plain old x. It's not squared, it's not hiding in a fraction, it's simple. And that's what makes a nice straight line. Now look at the other side. When you see things like x squared or 2 divided by x, you get all kinds of curves and wiggles. Those are not linear. We're just focusing on the simple straight ones today.
All right, moving on to section 3. This is where it gets really fun, I think. We're going to see what these linear functions actually look like when we draw them. We're going to turn that math equation into a picture. And here's a little spoiler: because it's a linear function, the picture is always, and I mean always, a perfectly straight line.
Okay, let's work through one together, step by step. We're going to draw the graph for this equation right here. Y equals 2x plus 3. Let's see how we do it. Okay, here is a super easy trick for drawing this. Let's just start with the simple part, y equals 2x. Don't worry about the plus 3 for a second. That line y equals 2x is just a straight line that goes right through the center point. Now what about that plus 3? Well, think of it as an instruction. It's telling us to take that entire line and just move it. Because it's plus 3, we move the whole thing up 3 steps. That's all. We just slide it up. And the fancy math name for that move, it's called a parallel translation.
Okay, on to section 4. We just saw how that plus 3 in our equation literally shifted our lineup, right? Well, that was the b part of our secret code, y equals ax plus b. So now let's take a closer look at both a and b so we can really understand what they both do. This is how you learn to read the story of a line just by looking at the equation.
First up is B. This has a special name, the y-intercept. It sounds fancy, but it just means where does the line cross the up and down y-axis. It's basically the starting point of your line. Remember our last example? Y equals 2x plus 3? Well, the line crossed the axis at the number 3. That was our B. So in this new example, y equals 2x plus 4, where do you think it crosses? You got it, at 4. It's just that starting number.
Now for the other part, A. This is called the slope, and it's all about how steep the line is. Is it a gentle hill or a super steep mountain? A lot of people call it rise over run, which just means for every step you run to the side, how many steps do you rise up? In our example, y equals 2x plus 3, the slope A is 2. That just means for every one step we go to the right, we go 2 steps up. That's its steepness.
And get this, just by looking at whether the slope is positive or negative, you know which way the line is going. If A is a positive number, the line is going uphill as you look from left to right. But if A is a negative number, the line goes downhill. It's a super quick way to know the direction just by glancing at the equation.
Okay, we've made it to our last section. We've learned all these rules and drawn some lines, but you might be asking, so what? Why does any of this matter? Well, it turns out this simple math is incredibly useful for solving all kinds of problems in the real world. Let me show you what I mean with a great example.
So let's think about a real-world problem. Imagine you're at the bottom of a mountain, and the temperature is a nice 15 degrees Celsius. But you know that as you climb, it gets colder. For every single kilometer you go up, the temperature drops by a steady 6 degrees. A starting point and a steady change? Does that sound familiar?
Yep, you guessed it. This is a linear function. So here's our challenge. Can we use our new math skills to figure out the temperature at the top of a mountain that's 1.7 kilometers high? You bet we can. Let's do it together. Okay, let's break it down. First, we have to build our function, our y equals ax plus b. So, what's our starting point, our b? That's the 15 degrees. And what's our steady change, our slope, a? Well, the temperature drops 6 degrees, so our slope is -6. That gives us the equation y equals -6x plus 15. Now for the easy part. The mountain is 1.7 kilometers high, so we just pop 1.7 in for x and solve it. And there we have it. When you do the math, -6 times 1.7 plus 15 gives you 4.8. So the temperature at the top of that mountain is 4.8 degrees Celsius. How cool is that? We just used our secret code for straight lines to figure out a real-world problem. And that's really the magic of linear functions. They're just a simple rule that can describe so many things around us, from how much a taxi ride costs to how fast you're traveling. So, now that you know the secret of straight lines, here's a little challenge for you. What other simple straight line rules can you find in the world around you? Thanks so much for watching.